After the virtual field trip focused on the extended outcrops of the Schrattenkalk Formation that are present in the Miroir axial depression of the Western Alps, let's give a look to some other outcrops, always concerning the same carbonate formation, but located about 25 kilometers westwards. These virtual field trips target people involved in a reservoir fracture study but not familiar with the geology. Let me stress again that caution must be utilized with what we can see on the outcrops, because fracture systems exposed, affected by late-acting processes like unloading and weathering, are bound to be different from the fracture systems of the reservoirs, which are located at several thousand meter burial depth. In any case, outcrops can certainly give some insight on the possible characteristics and complexity of the fracture network affecting the flow path in the producing field. Remaining in the Western Alps area, we move from the outcrops of the former virtual field trip located on the southern flank of the Schinderhorn Peak in the Miroir axial depression to a structural crest located about 25 km westwards. This crest is named Arête de l'Argentine. Actually, the general geological structural context is the same of the former virtual field trip, so we are in an area characterized by the helvetic nappes that are component of the very complex structural framework of the Western Alps. They can be exemplified by the sketch at the top right corner of the slide that represents the cross-section at the western edge of the antiphor. These different nappes consist in kind of overturned recumbent folds stacked on top of the basement massifs. For more details, you could make reference to the virtual field trip relevant to the Miroir axial depression or to the paper listed as references at the end of this virtual field trip. The geological context of this area is here summarized by the geological map northward of the Rhone Valley, by the 3D sketch of the antiphor, and by the two cross-sections at the edge of the antiphor, located at the bottom left and top right corners of the slide. The new area where we are going to focus the attention, that is the Arête de l'Argentine, is located westwards. So, we can move westward along the Rhone Valley for several kilometers until the town of Martigny, where the river Rhone sharply bends northwards along a strike-slip fault. Here, we can observe at the top of the mountain ridge, on the right flank of the valley, the spectacular outcrop of the Dent de Morcle peak, where the result of the rock folding and piling is very well shown. And then, just moving northeastward for a few kilometers, we can observe the outcrops of the Arête de l'Argentine, on which we are going to focus the attention in this virtual field trip. just another testimony of the Helvetic nappes piling. In fact, the Arête de l'Argentine, here highlighted in the topographic map, is a small fault inside giant faults, the Helvetic nappes, which are in turn part of the big folding of the Alps. Here, the geological map illustrates the folded stratigraphic sequence, where we are going to focus the attention on the fracturing affecting the C4, that is the Urgonian Schrattenkal formation, the same formation observed in the Rohwil axial depressions, but located in a different structural context. Actually, in the Arête de l'Argentine, the rocks draw a superb fold in the shape of an S. Inverting locally, under the Lion de l'Argentine peak, the vertical chronological order of the layers. Here are present a wide variety of limestone rocks, covering over 100 million years from the Jurassic to the Tertiary area. Focusing the attention on the Cretaceous interval, we can see, going upward in the chronological sequence, a sample of C3 formation characterized by yellowish-brown limestone of the Hauterivian age, a sample of C4 formation, the Urgonian limestone, very rich in marine mollusk fossils, and a sample of the T formation, Tertiary limestone, characterized by nummulites. C4 was the target of the former field trip and also of this field trip. The Arête de l'Argentine is a small fold, partially eroded on the southern flank, and shows the characteristic onion skin shapes, as illustrated by the geological cut here reported, perpendicular to the fold. It is like if we had a sliced onion with its heart located southward in the valley of Lavar, from where we look northward at the fold. However, the target of this virtual field trip are the quite steep outcrops of the northern flank of the Arête de l'Argentine. So, moving from the southern flank to the northern flank of this structural crest, we can enjoy the view of the almost vertical limestone beds that are named Les Miroirs de l'Argentine, an impressive challenge for rock climbers. Looking Les Miroirs de l'Argentine from north, as illustrated by this photo in this slide, the widespread presence of fractures on these very steep beds can be glimpsed. In fact, also the northern flank of the fold is partially eroded, and the outcrops show a sequence chronologically inverted, with a steep, almost vertical Cretaceous rock, the green C4, overlying the younger Tertiary T-yellowish rocks. Focusing the attention on the C4 rocks, the green one in the geological sketch, we see that it is strongly affected by fractures, very well exposed on the about vertical beds. Actually, it is a very extended outcrop, a wall covering more than 400 meters of difference in height. From afar, from the bottom of the valley, we can recognize several geological features. the bedding, one large fault also reported in the geological map, and some minor fault fractures. Try to make a closer observation. We can see in the upper part of the rocky wall a fracture network made by about two sets of fractures, almost perpendicular, like extensional joints, fold related. Moving downward and approaching the area affected by the minor fault fractures, we can observe as the fracture network change being affected mainly by events about parallel to the minor faults. Then, moving further downwards, the influx of the minor faults seems to fade, and the fracture network looks affected by just one set of fractures, probably corresponding to the second set of joints observed above the minor faults and just looking partially reoriented according to the folding of the bed. Of course, a closer observation could be useful to improve the recognition of the different fractures. In fact, the climbing of the very steep rocky wall gives us the opportunity to have a very close and detailed observation of some fractures that actually represent the main way to climb the very steep rocky wall. However, we miss from this point of view the general picture of the fracture system. A much better observation of the fracture network can be achieved actually from a drone view. Here, for example, from the lower part of the steep rocky wall, a wall very extended, as you can infer from the small size of the two geologists at work, as we can observe from the drone. Now, from a closer view of the two geologists at work. We can better appreciate the complex fracture network, probably fault-related but also affected close to the fault by tangential strain. Here the observation of the fracture network that can be achieved from the drone just above the former area. The fracture network that, far from faults, could be related to the combination of extension joints and conjugate shear fractures. Here the observation of the overlying area. likely affected by the presence of some faults changing locally the orientation of the fracture network fault related. Then let's go up to the final part of the rocky wall still affected by the fracture network. Up to the top, safe and sound. Just a few final observations. The AC extension joints appear to be quite irregular spaced, about 4 to 5 meters, and by far the most continuous event, extending along the vertical beds for several decades of meters. These very extended AC joints interplay locally with the about perpendicular BC joints that are by far less extended, generally less than 10 meters long. The fracture network so results locally very close and homogeneous. However, at a larger scale of observation, the role of the very extended AC joints seems to largely control the flow path of this rock that is likely to be very anisotropic. Here you can find a short list of papers to refer to if you are interested in investigating more in depth the geology of this area. So, an interesting view of the fracture network, but to be brought back always to reservoir conditions, therefore to be characterized and calibrated according to the dynamic data.